Okay, hello. Hope you sit well, because this presentation will take 20 years.
20 years of Scala development, ups and downs, what went good, went well and went bad. And of course, for Scala developers here in the room, it may feel like your CV, because it is definitely something that we have on our CV, the whole road. I'm Michał Płachta.
I'm Michał Pawlik. We're on the same team. We work for SiriusXM. We've been doing Scala for quite a while, so here's our recap of how Scala ended up where we are and where we're heading. So yeah, let's go back in time. Let's feel like it's 2004, and because we are young and ambitious, what are we doing? Well, we're writing some Java, right? So it's 2004, Java is in a state that couldn't be improved. It's missing a bunch of features like generics, it's missing annotations, enums, and a bunch of stuff. So this is a great moment to introduce another language that can improve on those things. So just to give everybody like a highlight where we are with Java, let's try to like have a look at collections and APIs. So this is how you would like construct an array list. Probably iterating over collections wasn't like necessarily like the most pleasant thing to do. You had some sort of iterators, those while loops all over the place. Everything was mutable. Not like very pleasant code to have a look compared to the new thing, new kid on the block, which was Scala. So immutable collections, great API for the collections, promoting functional approach with pure functions that were like filtering maps, all the things that that you see on the slide. So that is working with collections, but this wasn't like limited to the collections alone, right? If you wanted to model a thing, let's say an artist maybe. So in Java, typically you would have a lot of code if you wanted to implement something immutable. Java was not promoting the immutable approach. So it was inconvenient. People would just go to mutable because that was what the syntax would suggest them to do. Meanwhile, in Scala, doing the same thing, doing an immutable representation of your domain was very simple. And this is wow. This made immutable thinking, immutable data structures convenient, and that would promote functional approach, right? So this is the new thing. You're just learning about it. It's 2004 or somewhere close. And you have the immutable data types. You have pure functions all over the place. Concurrency should be much easier, right?
Yes,
right?
Yes, definitely. And we had futures. So futures were in the standard library. We had different approaches to futures, like Twitter had a future, and also later on we had a better future in Scala. So it allowed us to write asynchronous code in a much easier way. So let's look at this example, find artist, and please keep in mind this function because we'll use it later in the presentation. For this one, it's just like simulating something that could happen, like API fetch or DB fetch, right? Something like that. But for now, we just see an like JSON parsing thing. And here you can see that it returns a future. So when you call it, it will run in parallel, like concurrently, right? With some other stuff. That's how you do it in Scala. That's how it worked around these times and still. And of course, that allowed us to work on a value that will be available in the future when it's fetched or parsed or whatever. And we could still work on the value right there. So here you can see that we can map with a pure function and calculate like how many years that this particular artist have been active based on the value that it's still not there. And it returns another future of int this time, right? So it allowed this kind of chaining. And of course, you could kind of like attach a callback to print the value at the end of your computation when it's available. So this is kind of how it looked like using futures. But of course, that had some problems. For example, counter or mutable state in general, like this is a counter example. So you can see this, like when we have a mutable value that's initialized with 0, and we want to increment it using this function that simulates some work, and then increments the value at the end, and we run it like 100 times and attach a callback at the end. This will print the value. What this value will be, who knows? There are plenty of...
Ragdoll.
That's the best answer, I think. Since you're so good with answering, how do we make it better? Come on. Yeah. So this is what this is the next step that we want to cover, right? Because working with futures was great for like those functional in those functional ways. When you wanted to work with the state, you could have things like synchronized because we're running on the JVM. But at this point, we are the Scala community, people who try to adapt the language, and we try to like learn new ways to do things because we are learning this new cool functional language. We are trying to draw inspiration from like other places, and there is like one famous solution for like managing state in this distributed kind of way, which are actors, right? Erlang had them, and we were like, okay, maybe that's the solution. So part of Scala community definitely wanted to give it a try. But for those of you who haven't seen how actors look like in Scala, or what are they in general, here's a brief walkthrough. So an actor is a thing that can have a state and has an inbox. So it will take in messages to the inbox, and whenever it gets a message, it will trigger some logic. When actor is active, it will occupy a thread. Otherwise, it will be just idle. And you need probably some sort of runtime to execute the actor logic whenever it needs to, whenever it gets a message. So this will be like the new syntax for Scala, like Scala 3 approach, but the principle is the same, right? So whenever you wanted to implement an actor, you needed to define a protocol. So here we have message that can be either increment, to increment the counter, or reset to make it to 0, right? And then the behavior. And for those of you who like were paying close attention to the previous snippet, we don't have any var here. So in some of the implementations of Akka or actors in general, you could have var. In this one, we went with this recursive approach, right? So we describe the behavior about what's happening when we get the increment, what's happening when we get an reset, and then proceeding to like the next iteration. And then we were creating an actor, and we wouldn't care about how it happens that it's executed. There is an actor system for that that would decide which threads are occupied or not. It could be like even like distributed system. It could span across multiple nodes. So that was a really promisingly design. And talking about design, because we've been talking about finding actors, right? Let's try to re-implement the future in this sort of way where we have this kind of actors guild. So I can ask about the actor and I will receive some sort of response, right? The design of your program changes drastically with introduction of actors because actor is like your logic component, like the module of your application. So bird's eye view on this design, we would have a client that requests an artist, and there is this actor as a black box. But probably it wouldn't know all of the state internally. It will like delegate things to the database. Or maybe if we're having like very large application, the actor would actually have something behind it, like more actors that would have their own data sources, right? So there are things that we needed to consider as far as design goes, and that would everything be actor further down, probably. So there was some slight inconvenience. I'm not only talking about the design, because let's have a look again at the counter. Tell me, when is the behavior invoked? Like, how do I know? With the previous design, when I just had a function, I could just go in my IDE, click on my function, and ask my IDE, okay, who invokes it? But with actors, I only have those messages. So probably my best bet is to see who creates the instance of increment or reset and just hope that they really sent it at some point. So if you're new to a system and try to like discover how it works, well, maybe that's not very convenient. So that's one thing. Then going back to the designs, we were deciding if we want one big actor that handles all of the logic, or maybe plenty of smaller actors, right? And there wasn't a silver bullet. You just had to make the call and hope that it is right. And there were also other challenges like life cycle, testing, and other stuff. But people were successful with running actors on scale at some companies. So it's not like the design was bad. It just was challenging, but it allowed you to manage the state. So if state was your thing, probably that was something to work with. In the meantime, there were other people for whom the state management may not have been the biggest problem, but they would complain about eager evaluation. So what's eager evaluation? Let's have a very simple example. There are two futures there. It's not very important what they do. They don't do much. They just print something, but they might as well like write to database. They might read from database, whatever. And you have this decision function. So it will do one or the other future based on just input, right? If the input is X, then go with X, otherwise go with Y. Now let's execute it. And yeah, you tell me what the result will be. There's a hint. Well, both futures will execute because they are not lazy, they are eager. And if you're not very like well versed with designs based on futures, you might miss that. Sometimes you might be doing like extra work with futures. Sometimes you might have very quirky behavior that would stem from the fact that the future starts immediately. So again, we are in this new language. We are trying to do our best. We are looking for like safe, convenient solutions. And we draw inspiration from other functional programming languages. So we spoke about Erlang, but some people draw inspiration from Haskell. So they were like, okay, if only future was lazy, this would be the world we live in. This was the claim. So what was the change really as far as the syntax goes? On the surface, it wouldn't look like much, because if you were writing futures, you would just wrap a thing in the future. But with IO monads that came from Haskell, you would write this thing. It's just the name of the type, right? The slight difference is that you need to explicitly run it. So probably you want to create a bunch of those IOs, somehow make them run one after another, maybe with flat maps, maybe with other combinators, and then only execute this thing at the very end. But if you think about it, that's almost meta-programming. Like, you construct your program in one place, and then you run it in the other. So, yeah, at this point, IO monad was just like a growing thing, and people were like, okay, that sounds cool, the promise is there, reasoning should be easier, but remember that we are like still very early on. We don't have any IO monad, so everyone is tempted to write their own IO monad, right? And we did. We did Scala Z, we did Monix, then we did Katz effect, then we did Zio, Kio, yes, like plenty of them. And at this point in time, like today, we probably have some of the implementations that we're very confident with using, but along the way, we didn't know. Like, we were this JavaScript of JVM, a new library would pop up every day, and I would be like, okay, the Scala Z name maybe sounds cool, so let's pick it, but what if it gets abandoned? Am I confident enough to use it in production? So that was a rough choice. We're at the place where we have some like well-settled, well-established libraries that we can use to implement like the counter logic, for example, and they feature their own like standard libraries. So we have like safe concurrent queues, we have refs, we have resource management and more. And that's cool. We stepped into the world of monads, but effect monads is not the only monad that I have in my program. Is that right? In the standard library, you already have some monads. They may be not called this way, but you have like list, option, either, this kind of stuff. And they were cool, and they are there for a reason. We shouldn't be avoiding them, right? Going back to our artist example, there was like slight issue with the design, because here we try to find the artist and then just reference the head. What if the list is empty? Like, my future will probably fail. But the standard library already like had a solution for that. We had either that we could like represent the final value with, right? We could first wrap it in IO because that's the new cool thing, then we wrap it with either, but now we end up in a situation where our code is not convenient anymore. Like, obtaining the value requires me to go like 2 loops around my value because I first need to terminate the IOs, then fetch the values from the either's. So we've been trying to chase the solution. And one of the cool things that someone spotted was, okay, there are those monad transformer thingies. So let's just take my IO of either and turn it into a single thing, right? Either T. And because monads do not really compose well, there was like no generic solution of the single monad. Whenever you wanted to combine one monad with the other, you would have this T variant of either maybe of state, maybe of something else. So on the plus side, it would make the code readable again. On the minus side, there is some overhead in the syntax. And yeah, this could get out of hand pretty quickly. Like when you were designing an application, you could end up with single effect for your whole application that would be like terrible to read. And if someone was joining your team at this point, you would have them look at this type and they would be confused, like not understanding anything. What does this thing really mean? So yeah, some people were like, okay, we can just onboard people with that. We can document that pretty well. That would be fine. Some others would say, okay, let's hide it. Let's abstract this away. Maybe we can just shift it somewhere else so that we don't see it in our like code bases. And yeah, in between like maybe 2015, in between the 17, sorry for that, we started experimented with tagless final. So the premise was, again, pretty nice because we wanted a simple code. So our find artist would be, some would say algebra or just an interface that takes in a name and returns an artist in this future-like thingy, whatever that is. And this is the approach we are taking. We don't want to speak about any particular monad here. We just program to an interface. Sounds like a clean code thing to do. So we like sort of go somewhat like we did with I/O, right? We wanted to shift the runtime. Now we shift the monad further. And we could do various implementations. So we could use the implementation that we already had with this find artist. But if someone came, okay, that effect library is not great anymore, maybe it's not well maintained, we could shift to another implementation. Like we wouldn't even like need to use MTL if we decided it wasn't cool. So at this point, we have this F, we have the general abstraction. We can decide if we want MTL or if we want this very like beefy monad, Zio, whatever. At this point, I suppose everyone is supposed to be happy, satisfied. They can choose what they want. Is that right? Well, they don't seem satisfied. They seem to be laughing.
Yeah. When you look at the signatures like that, they were all over the place. But to answer this question, we need to go back in time, and we'll get back to this question and try to answer it later on. But before we do, we need to kind of like start fresh and go back in history and try something more practical. Who here is in a startup or develops something as a startup? So you, yeah, plenty of hands, a couple of hands. But so you know exactly what's the most difficult thing to do when you are a startup, right? It's choosing your HTTP library. That's the point, because when your startup fails, it's 100% because of you choosing the wrong one. So let's go back to 2013, around that. So people were choosing things like Scala. So it was a port from Ruby, and it was a it is a micro framework, still actively developed. And you could pretty quickly write your server just by showing the endpoints in one file and have it running. So that was the premise. Micro framework, pretty quick to do. And we will show you this one and the next iterations of how Scala ecosystem developed HTTP servers in this part of the presentation, so we can answer the question you posed. And the example would be the artist collaboration. So basically an HTTP endpoint that gets two parameters and answers one question, whether two artists could have collaborated with each other. So for example, curling to collaboration, artist 1, Frank Sinatra, artist 2, Aretha Franklin, and the response from the server should be that they both could have collaborated between 54 and 95, and they did collaborate, so that's pretty nice. And to implement that in Scalatra, again, micro framework, we first start with a model, immutable class artist you've seen already, and you need this collaboration servlet that extends Scalatra servlet, and you just say get collaboration, that's the endpoint definition, and inside this you have an endpoint implementation. So in this case, it's just find artist that you saw before using futures. And because it uses future, you need this kind of like a future support trait mixed in. And of course, since we are parsing JSONs in the find artist and also could add some APIs to that, JSON APIs to that, we need those implicits for formats and for execution context, so the thread pool, right? That's how it looks like, the whole implementation. So it's pretty nice, very quick to write. And of course, you need all those things together. You have them available at your disposal when you just import your Scalatra thing. So everything is there. Every integration is very similar. So for example, if you'd like to add a DB, you just need to add it to the lifecycle. And then you have this dev-DB database you have at your disposal, and you can run your queries there and return them to your clients when the HTTP endpoint is called. So it's very cool, very quick and easy to do. And this brings us to the part when we can try to judge and try to rate how was it to use Scalatra for your HTTP endpoint, and then compare with the next ones and with others. And we'll use this kind of like quadrant diagram. So confidence and safety. Higher confidence is to the right, and higher safety is to the top. So the best one is the right top quadrant, right? So for Scalatra, let's see where should we put it. I say it's everything in one place, as you've seen. Is it to quickly write something that works? Because it works. It's just one file. You just say start and it works. Based on servlets, very stable, well-tested technology, right? And many stable integrations for databases, JSONs, what have you. It's really there, up there. Who's with me?
I'm not.
Okay.
I would know why they are not as well. Like servlets, really? Deploying servlets, having them locally, it's inconvenience just by the name, right? Then bigger apps, how do you rewrite a thing that extends 20 traits that have different sort of context and other stuff? And then how do you test the thing with servlets without pure functions? I would say we need to go towards more safety than convenience.
All right, and that's what happened, really. Scala devs kind of looked at the convenience that they took from the Ruby world, but also they had these tools at their disposal, like type system, for example, right? And many other tools, and people experimenting with that. So they kind of like turned to safety and try to implement some nicer HTTP things with these mechanisms. And meanwhile, as we've seen so far, there was like futures around this time, and of course, actors for concurrent systems. And every time in the Scala ecosystem, there is like a paradigm switch. In this case, like, okay, synchronous Java++ to like futures, asynchronous, and actors. Something happened. And this something is new DSL for HTTP library, right? That's what we did, because Scala developers love the new DSLs. And that's what happened when we switched to actors, because HTTP kind of like brought a new DSL to the table. And that DSL, HTTP again, now HTTP as well, looks like that. You have this nice thing, because it's just route is your endpoint, is your immutable value. That's different to what we've seen with Scalatra and others. You define path and what kind of requests you can have like that. But also the next good thing, the improvement here, was that the artist 1 and 2, so the parameters you have in the query, are kind of like extracted for you, and you can just use them as function parameters. And of course, since there's HTTP based on actors, you could also use the underlying system, actor system, and futures to write your system, internal system. You didn't have to do anything more than that. So that was the paradigm shift. In this case, you just ask the actor. It does its thing, as Michał described earlier, and then you have a future out of it, and you can kind of like add a completion based on what kind of result do you get back. So now we can see that this was an improvement in some cases. I would say endpoints as values, pretty nice improvement. Also, concurrency using actors, I think both safe and convenient. So I'll put HTTP right here, and I hope now everyone's with me.
I'm not. Yeah, some of them are laughing, so they are not as well. Did you listen to my complained about Akka, discoverability, code navigation, right? It's not that convenient to navigate, especially if you do too many actors in the backend. So that's not great. Also, you base on future, so it's still like eagerly evaluated. There might be some bugs out of that. And then future alone, it's pretty powerful, right? You're not constrained. You could like launch missiles out of like a future, and that would be something you don't control too much, right? So I think we need even more safety.
Okay, I can agree with that. So the Scala developers agreed as well, and they tried new things and tried to be better at that, going to that top right quadrant. And we've seen the find artist implementation earlier, right? We got this future of either, maybe IO of either, also IO, and the exception kind of like hidden inside IO, and also like MTL or like tagless final approach as well. So this kind of like paradigm shift was into like lazy evaluation stuff, more things that are under our control, IOs and tagless final, more abstraction and separation of concerns. So that was the paradigm shift. So IOs and final tagless everywhere, which means that we needed another HTTP DSL, right? Because that's what happens. It's a normal way of living, and that was HTTP4S. So we kind of like have a library that has this all inside built in, and this is quite a nice example of having a library that kind of guides you into a specific implementation, a specific design in your application, like the others probably. But here you can see that it's the application you build usually, it's already designed in a specific way. So for example, you have a trait and interface of your endpoint implementation, right? We know it's a collaboration that will get two artists and will return something like a string with the result of the artist. And endpoint is defined in another place in your code. It's just the endpoint definition, like the get and collaboration, 2 parameters, and then something will happen like an HTTP error or HTTP result, right? So that's the endpoint implementation, totally independent of the implementation of the collaboration trait, because it's like a separate place of code when you really implement the endpoint. In this case, it's just sequential find artist, and then running your check collaboration pure function logic, right? So that's how it kind of like drives the implementation of your HTTP server because of this paradigm shift that we had. And now what we can do is we can say, okay, now we have fine-grained control over everything because separation of concerns, also type, like tagless final as well with specific requirements for a type. Structure concurrency, lightweight concurrency, lazy evaluation. I think it puts it in the right quadrant, like the top right quadrant, right? But I don't want you to say anything because, okay, large complicated signatures, it's a thing. It kind of like virally goes up in your application. So when you change something down in your application, it bubbles up when you change the signature. So it's not that convenient. We need to move it a bit left. And of course, people, since it wasn't that convenient, started using like a sync type class to everything. And the sync is basically just IO or whatever. So it's still too powerful. Yeah, that means probably we need it a bit lower on the safety axis. So what we wanted was a switch to safety, and we did get some, as you've seen, right? We are moving up, but at the cost of the convenience, basically. That's what happened. But we still learned a lot. Immutable values are cool, like back to the basics. Pure functions are cool. Expressive types, lazy evaluation, all those things, cool. And we kind of like make those learnings into something productive, into something tangible with Tapir, like we as an ecosystem, obviously. But Software Mill produced this one. It's a game changer because it kind of like uses everything that we've seen so far. Like, for example, this collaboration endpoint it's just a value, right? In collaboration artist2, string body, error, you know everything about it, right?
Yeah, and that's actually a big thing. This is the first proper value that we see. We had like things that have been whole roots, but this is the first endpoint description, meaning that you can copy the endpoint over and just have one get, one post thingy. You could have all of the information about the type inside. So you can generate documentation, specification, whatever you want. So this is like the proper value that you can manipulate Yeah, that's a big thing. That's like well-designed API, I would say.
Yeah, and the implementation itself as well, it's just a function. No strange types. You can implement in whatever way you want to implement it, so you can use whatever paradigm you want to use as well. And of course, the server itself, it's just like a IO value as well. You just add this endpoint, your value here, and it's all running. So very quick and convenient, I would say, to use as well. And of course, you can pick any server you want because those implementations are switchable. So at the beginning of your project, you can just choose whatever that's the server that you need really there. So it's also very flexible in that matter, right? So when you look at it, it's definitely something that you should be able to put in this high top right quadrant, right? Immutable values, pure functions, low-cost stable integrations, and of course, the HTTP domain model there is pretty nice, like using types, and you know what exactly can you do with that builder pattern function. So I would say, answering your question, when you go back to this one, I would say that's pretty good thing, like tagless final, because when you look at it from this perspective, the Tapir is implemented using this approach, but under the hood, right? So we still use a lot of those things, the power of this abstraction over there. It's not really exposed to the user in the similar thing as on this kind of like snippet, right? So it's possible to do it, and it's a nice tool, but you still need to think about your domain you are modeling and be able to use it. Does it make sense?
Yeah, makes a lot of sense. So you can benefit from the goods of tagless final by carefully designing the library. And yeah, tagless final brings a lot of things to the table, like good testability, because in tests you can like use just like an option maybe, and in your proper code use the effect you want. When you ship the library like Tapir, you allow your users to decide about the final effect, right? There is some readability and cognitive load, but this is something that the experienced Scala user, who is like the library author, probably can handle. So yeah, I would say tagless final is not the dead end for like developing stuff in Scala, but it definitely has room for it, right? If you haven't seen it, on this year's Scala, there was a talk by Noel Welsh, who actually explains the concept of properly designing a library and an API based on tagless final that is not leaky. But yeah, tagless final is not the dead end because monadic effects are not the only option to like use to structure your application. And happening now as we sit here are Capybara project. Martin spoke about it just this morning, right? There is Gears. There is Ox by Software Mill. There is the cool library that we learned from Szymon about Cyfra, so running JVM code, but with GPU integration. There is also Kyo that I'm not going to cover today because right after us there is Fabio who is talking about it on the big stage. So I wanted to say that we together are done, but Scala community is not. Scala community is a community of people who draw inspiration from other languages, who are very ambitious, who want to like chase even better solutions. So we encourage you to keep exploring, get inspired by other languages, by other people, have fun coding, and with that we want to thank you.
Thank you.
Thanks for a great talk. It was very knowledgeable.
Thank you.
Any question? Can we use that microphone? Could you try it?
Raz, dwa.
Wait, here it.
Yeah, one question about comparing Tapir to Scalatra. Why do you think Tapir is less convenient than Scalatra?
Oh, that's a good question. Let's see. All right, so my idea was, maybe Michał disagrees as always with those quadrant diagrams, but my idea was that in Scalatra, it's very convenient to like set it up. And you just one file, you just save everything in this one file, very small ones. You don't have to do any like IOs like with Tapir or any like servers choose because it's chosen for you, right? The servlets are just deployed to the Tomcat or something like that. It's chosen for you. You don't have that choice with this particular code base that you're running. That makes sense? But I needed to go back to the slide, but it's a small difference. Small difference.
Yeah.
Make sense? Thanks, Jack.
Any other question? Feel free to raise a hand. No questions. So let's give once again a big round of applause for Michał and Michał.
Thank you.